Good morning, girls. Uh, in the last class, we have seen circular linked list, and today we are going to discuss about linked stack. So, what is a linked stack? So, the name itself is saying you something. So, a stack implemented using a linked list is called linked stack. So, here is generally a stack is implemented by using arrays also that you have seen in your chapter 3. So when you try to implement stack using array, so there are limitations to it. There is a limitation, one major limitation, that the stack cannot grow or shrink dynamically. So you have to allocate fixed size of memory, and that would be the size of your stack, and can't grow or shrink depending on the requirement. So that was the major drawback in the implementation of stack using arrays. So this drawback can be overcome in this linked implementation, linear list implementation, linked linear list. So that uh, implementation is what is called as linked stack. A stack implemented using a linked list is called as linked stack. So how this is implemented actually? So each element of the stack will be represented as a node of the list. So the elements which are stored in the stack are represented as nodes in the list. So one element corresponds to one node in the list. So the addition and deletion of a node will only be at one end. So in stack, the main principle is the addition and deletion, or pop and push, whatever you call. So those will be only from one side, one end of the stack. So the first node is considered to be at the top of the stack, and it will be pointed by a pointer called top. So we are assigning a pointer called top, which points to the first node of the list. So this will be the first node of the list, which is pointed to by the pointer top. So the last node is the bottom of the stack. So the last node will be the bottom of the stack, and always the last node is set to null in the linked list. So here also it is set to null. So to signify that it is the end of the stack. So an empty stack will what it represents, top is equal to null. So the pointer top, which is set to null, which means that there are no elements in that particular stack. So if you try to represent these three elements in the form of a stack, if you want to put it in the form of a stack, so this is how it looks like: x, y, and z. So x is treated as one node, y in the second node, z in the third node, and this is your last node. So this is your symbol, earthing symbol, and this is the pointer, top pointer, which is pointing to the first node of the list. Next, so here the top is a pointer pointing to the top element of the stack. X is at the top of the stack and Z is at the bottom of the stack. So this you should treat as the top, and this should you treat as the bottom. So this is the topmost element and this is the bottom element. So one thing we see here is single linked list is suitable to implement stack using linked organization. Why? Because the operations are done at one end of the list only, single linked list. We will be adding at one end only, or addition or deletion will be done at one end only. So the best suitable list variant for representation of stacks is single linked list. So how you will define a class or write a class for this linked stack, how the node structure looks like. So this is the program for it. So you will first declare a class name stack node. So that stack nodes in that stack will be having two parts, two fields One is the data field, the other is the link field, and the link field is again of the which type? Stack node type only, data type only. Why? Because it is a pointer. This is all we have seen in the previous topics. Next, class stack. So actual implementation of the stack here. This is how you define the nodes in that stack. This is the stack structure. So private, you're declaring these variables as private so that the access is limited. Stack node is pointing to the top. So the point top first node is nothing but stack node, which is nothing but top. Next, int size. Int is empty. So you will, if you want to find out the size of the stack, so then you can use this variable size. And also if you want to check whether the stack is full or empty, you will be using this method. Next, stack. You are declaring method. This is a constructor. So because this have the same name as the name of the class. So in that constructor, you are initializing the top pointer to null and size to 0. Initially the stack is empty when you create it, right? So you are initializing the top pointer to null and the size of the stack is set to 0. And these are the methods which through which you will work on this stack. First one is get top. What is the topmost node or of the stack? Next, how to get that data pop. Next, how to put an element into the stack push, and what is the actual current size of the stack. Because we are implementing stack through linked list, it is dynamically growing and dynamically shrinking. So there is no set size. So to know the current size, so I mean what are the number of elements in the stack, you will be using this method. So here any type of data can be stored, that is int, char, float, struct, and so on. All the whatever data you want to store, you can store in this data field, because already we have discussed node will have two fields. One is link field, one is data field, and data field can store any kind of data. The link field is a pointer pointing to the node below it. So here the link field in the node, any node in the stack will be pointing to the next node. Next node in the sense the node which is below, or we call it next to it. So what is the purpose of the top? So the top serves the purpose of a variable associated with the data structure stack here. So to point out the first of starting of the stack, or to represent the first node of the stack. To serve all these things, we will be using a pointer called top. See, the what this top will contain, this will contain the, this will have hold the address of the node. So it tells you the starting of the stack. So this is where the first node of the stack is. That is what the top points to. So it is a pointer rather than an integer. Next, to represent an empty stack, top is initialized to none. So when there is no empty, there is no node or no data in the stack, the top is initialized to none, so that it can tell you that the stack is, it conveys that the stack is empty. So every insert and delete of a node will be only at the end pointed by the pointer variable top. So this is what the most important part of this implementation is. So the insertions and deletions should be only at one end. That is what the principle of stack is. The insertions will be only from the top, and deletions will be also at the top. Upper part of the stack. So here we are restricting the insertions in of this linked list or deletions of the linked list only to one end. They have to be done at the end where the top is pointing to, the end pointed by the pointer variable top. Then only it will follow the mechanism of a stack. In general, linked list can delete a node from anywhere, insert a node anywhere. But that is not what we want here. We want to work it like a stack. So the insertions and deletions of a node will be only at the end pointed by the pointer variable top, so that it works with the logic of a stack. So this is how the insertions and deletions happen. Uh, so we are using these commands: create, push, push, pop, push. So for these three elements, we are trying to create a stack. So how it will work? Let's see. So create S top is equal to null. So first you are creating a stack called S, and you are initializing top to null because it is empty. So onto that empty stack, you are pushing the elements. So Z should be at the bottom. So the first element inserted here is Z. So the top is pointing to Z. So push Z. Next push Y. Next, you are popping up. I mean, we want to say show how the items get deleted or nodes get deleted. So if you say pop, the uh, node which gets deleted is this. Why? Because we have already stated that every insert and delete of a node will only be at the end pointed by the pointer variable. So this the latest node which is pointed to by the top is y. So when you're saying pop, so this node will be deleted, and z again the top is set to z. Next x, you are trying to push x, so the next you will insert a new node, and the top is set to point to that new node. So the stack grows and also shrinks at the top only. So what are the operations on stack? So what are all the operations that you can perform on a stack? So the memory for each node is dynamically allocated on the heap. So that is what, for that advantage only, we are trying to implement a stack using a linked list. So the dynamic allocation of the memory has to happen for each node when you ask, or when you try to insert a new node, or when you try to delete a I mean node, the things should be done dynamically. I mean, the memory has to be allocated and released dynamically. So when an item is pushed, a node for it is created, and when an item is popped, its node is freed. Okay, so when you try to push an item, when you try to insert an item, send an item into memory, a node for it is created. When you try to pop, I mean, when you want to try to delete it, when you try to remove it, so it is free. The only difference is that the capacitive linked stack is generally greater than the contiguous stack, since the linked stack will not become full until the dynamic memory is exhausted. So already we have seen how the memory allocations happen in the program. So the dynamic part is heap allocated in the heap memory. So until and unless the heap memory gets exhausted, your stack can grow and shrink dynamically. So the limit of your stack will be the size of the heap, which grows and shrinks dynamically. So this is the how the operations are performed on the stack. Let's have a look. So this is the logical view of the stack. So again, we have seen we have first created class called stack node, which is a self-referencing class, sorry, a variable. So your link will be of the same type as the stack node. Next, stack is the class. So in this class, you are declaring some variables as private in order to restrict the access. So you are first initializing this stack through constructor. In the constructor, you are uh, saying that it is a null or empty stack. Um, now you define the methods here. So the first thing is first method you are defining is empty. So what you are doing here is you are checking if top is equal to null, it will return 1. If it is not null, it will return 0. So first you will check whether the stack is empty or not. So once you check if it is empty, you can insert directly, or you will see what is on the top. So get top method. So if it is not empty, so this is the negation symbol, right? So is empty is opposite not empty. So it will return top data. So the data which is pointed to by the top point. And the node data in the node which is pointed to by the top point. If you want to read the top. Yeah. Next, push. So this is the main operation that you do in the stack. So when you're trying to insert a new value into the stack, first you will declare a new node which is of the stack node type. Stack node is nothing but the class. So every node is treated as an object of this class. So new node is equal to new stack node. So this is how you are allocating the memory. You are doing the allocation. Next, you are putting some value. New node data is equal to some value into that data field of this new node, and new node link is equal to null. You're setting the link part of the new node to null because there is no next element, and the new node link is set to top if it is the one and only empty I mean element in the stack. It is set to null, and it is top is new node. The top will be your new node. So new node link is equal to null, new node link is equal to top. So both are uh, if signifies that there is only one element in the stack. So top is equal to new node. So always we have said that insertions will happen at one end only. So whatever new node you insert at uh, top, the top should point to that new node. I mean the end which is represented by the top, where that is where the new node insertion takes place, and your top will now point to the newly inserted node. Next, stack pop. So how you will pop? Again, you will take a temporary variable called temp, and you are setting it to top, and data from that temporary node is taken out, and if it is empty you will set the top to top link. So the data is getting deleted, so you have to move to the next node. I mean that node is getting deleted, so you have to move. The link should point to the next node, so your top should point to the next node. That is the reason your top is equal to top link. So till now whatever was link was there in this top node, that link will be set to your top. Next, delete temp and return date. So this is how your push and pull is taken. So the top is initialized to null to indicate empty stack, and push function is used to create a node dynamically. And after creating a new node, the pointer variable top should point to the newly added node in the stack. So this is the most important point here. When you are inserting a new node, the top variable should always point to the newly inserted node of the stack. So this is how you implement a stack using linked list, which is called linked stack. In the same manner, we'll see linked queue in the next class. Have a nice day. If you have any doubts, ping me in the group.